The basic concept of the open market is hard to improve. Whatever the item, the idea that buying by sight, in person, through choice and examination of a seller's merchandise is a most satisfying guarantee of value. Look at the beautiful new drugstores with their open displays and logical departmentalization. And the magnificent new supermarkets. Both actually spring from the same concept. Recognizing this basic appeal, especially in self-service shopping, they too are geared to sight purchases. And with the merchandise in plain sight, there's added stimulus and incentive for the maker of that merchandise. For it is often much more than a slogan that only the best can stand the test of being seen. And because you can know a product better by seeing it, we'd like you to see Owens-Illinois on film and with an expert guide to tell you about it.
Hello. Been expecting you. I'm Jim Lamson, your guide through the plant, and very happy to have a chance to show you around. The plant you're about to see is a composite of more than a dozen strategically located from coast to coast and serving customers through branch sales offices all over the country. Before showing you the sequence of actual operations, I'd first like to have you get an overall picture of the plant from this cross-section panorama. The arrows trace the flow of raw materials from the storage bins into huge traveling buckets through the batch hoppers and automatic batch feeders into the large melting area of the furnace. And from here, the melted and purified portion, which sinks to the bottom, flows through a throat into the smaller refining chamber, then passes into a revolving pot. This is one type of forming machine. It deposits the glass containers onto a traveling conveyor that moves through a long annealing oven, then into the inspection and packing departments for final handling before shipment. Well, now that we have a general idea of where we're going, what we're going to see, let's go out into the plant and see the actual operating steps in making glass containers. Large quantities of raw materials are delivered to the plant daily to be combined in a mixture called the batch. And here in the batch house, you see the control panel where weighing and mixing is regulated. In fact, on these automatic scales, a variation of only 4 ounces in a 4,000-pound batch will stop the operation. Filled buckets of the batch are propelled on overhead rails to hoppers above the melting furnace. It's released through chutes into a channel where it's churned through a special automatic screw-type conveyor into the simmering mass of liquid glass. And now the furnace itself. This 200-ton inferno with its blinding glow of molten glass has a temperature of around 2,700 degrees Fahrenheit. Here's something being done especially for you. Removing a furnace block for a look inside. The raging torrent of flame you see is a few feet above the glass level. When the thoroughly melted ingredients sink to the bottom, the purified portion flows through a throat in the furnace floor into the refining chamber. Operating constantly, day in and day out, these furnaces literally burn themselves out and must be completely rebuilt about every 2 years with special refractory materials. And now, here's where the forming operation enters the picture. Here's one of the 2 basic types, an Owens vacuum machine, a spider-like monster with an insatiable appetite for molten glass. Listen to it. Spinning round and round as its many arms dip into the revolving furnace pot, each drawing up a part of the fiery liquid. A blank mold on each arm gulps a measured amount of glass by vacuum. Look, you can actually see it drawn up. That huge knife severs the gob at the base of the mold. Here in animation, we see how the glass is drawn up inside the blank mold by a vacuum, filling the entire space, including the base of the neck and the finish. A cut-off knife shears the glass and closes the opening. Then the blank mold, which governs the preliminary shape of the container, moves away, surrendering to the finish mold, which rises up and captures the suspended slug of white-hot glass. Again in animation, here's what happens inside the finishing mold. A jet of air is forced through the throat, blowing the glass to the shape of the mold. These red-hot, fully formed glass containers are now ready for the annealing oven. This gigantic machine produces extra large containers as big as 6.5-gallon carboys from molds weighing up to 500 pounds each. The machine itself weighs 125 tons, stands 22 feet high, and has a diameter of 19 feet. It's the only one of its kind in this country to turn out automatically commercial glass containers of this size. As mentioned before, Owens-Illinois uses both basic types of automatic forming machines. In fact, we're the largest operators of gob-fed machines in the industry. In this so-called flow or gob process, the molds are filled by gravity. These are the charges of molten glass of predetermined weight and shape. And here, synchronized with the forming machine below, the charges are being delivered to the molds. You notice that the transfer of glass from the blank mold to the finishing mold presents a picture quite unlike that of the vacuum machine, but the actual forming operation within the molds is identical. Let's watch the forming of several different items on these flow machines. Since glass, like steel, has to be tempered for strength, these containers must go through an annealing layer. Once inside this oven, the containers are first reheated to about 1,000 degrees to attain uniformity of temperatures. Then they are moved slowly through gradually diminishing temperatures until the cool end of the layer is reached. Annealing time for the average container is between an hour and 1.5 hours, depending upon its weight and thickness. Every container emerging from the leer must now run the gauntlet of specially trained selectors who skillfully scan each container for any imperfections. But the checking of containers is not confined to this visual inspection. Many other tests are made at all stages of manufacture, such as the checks made right in the forming department to ensure top performance of the machines, by the machine operators, and by the line supervisor. And behind the scenes at every plant are quality control laboratories where technicians regularly take sample containers from each production line and check them against standards set up for strength, annealing, capacity, weight, and many other factors. These activities supplement the work of a central clearinghouse in Toledo on all quality control testing and analysis. And in the tremendous central mold shop of Owens-Illinois, expert craftsmen literally shape Duraglass container quality in the machining and hand tooling of container molds. For in these highly polished molds are first mirrored the precise accuracy and visual appeal identified with the Duraglass name. The ever-increasing use of durable applied color lettering, or ACL, bears convincing evidence that it not only enhances the attractiveness of all types of glass containers, but it's immensely practical as well. This is the start of a 3-color application. Each ceramic color is applied automatically through a metal screen, fine as silk, with all the meshes blocked off except the parts where coloring is desired. The pattern for each color has been transferred to a sensitized screen like this from a negative of the design. When washed, the design shows up on the screen as the transparent area. After the first color is applied, the bottles move along into a dryer. When the color is hardened sufficiently, the same procedure is followed in the second application. And then the third application, both red and blue. Coming from the drying oven, the complete application is subjected to inspection. Then the bottles go into an oven similar to annealing layers, where the ceramic colors are fused onto the glass. So the decoration from the glass-on-glass application actually becomes a part of the bottle to make a brilliant, lasting impression. Now, Owens-Illinois is not only a glass container manufacturer, but a maker of complete packages, including closures and corrugated and wood boxes, each a big and important story in itself. For example, it's part of the Quality and Specifications Department's job in each plant to constantly check the materials used in cases or cartons and the finished units. Here's a plastic cap operation, part of our complete closure production. You see the rotary molder turning out caps under heat and pressure. And the flash, or excess material, being removed through vigorous tumbling contact of the caps within this spinning squirrel cage. Dies simultaneously cut and press liners into caps. The liner material, of course, depending upon the product to be packaged. After this final inspection, the caps are weighed into cartons and tightly sealed for shipment to the customer. Incidentally, many different plastic items are made by Owens-Illinois. On the opposite side of the closure operation, our metal cap facilities cover a wide field, and again, a story of quality procedures that would alone justify a complete visit. But making glass containers, closures, and cartons of consistent high quality isn't the whole picture. That's why we place so much importance on our research and development activities. Here is the home of our pure research in the chemistry of glass and methods of producing it. Another facility is this Duraglass Center, an entire building devoted to making our products more practical, more economical, and more profitable as they are actually used by our customers. People here in the Duraglass Center are looking for trouble, rather hints of trouble, which might inconvenience customers at one time or another. It's their aim to prevent all possible package difficulties before they can actually occur. And the same holds true in the development and testing of shipping cartons. Here are devices designed to simulate actual handling and shipping conditions, and then some. This is where they create and engineer container design through the blueprint stage. The model shop, where three-dimensional reality is given those blueprint drawings. And there's no missing the world's largest display of current stock in private mold bottles and jars, numbering over 9,000 different containers. Here, they create the label designs used in applied color lettering, or ACL decoration. Around this department, they're concerned with the development of functional cap design and machine design, parts manufacture and assembly, and testing. Doing such things as finding out how tight a cap should be to get a proper seal with appeal for the consumer. You'll find a miniature packing plant where cannery or glass packing procedures are duplicated in both operations and equipment. You'll find food technologists and chemists studying ways to improve the quality of food, making it look more naturally appetizing, and finding what it takes to prevent spoilage. And here in the analytical laboratory, they concentrate on the chemical and physical analysis of both packaging materials and contents in all types of packaging. Now, no seal-type container is better than its closure. That's why a major activity is closure and cap liner testing under diverse conditions. Engineering development and service activities are geared to provide assistance in the laying out of a plant's glass packing lines, analysis of equipment operation, the selection of equipment, and the development of needed machines if not available otherwise. These artists originate design for container, label, closure, and carton for a completely integrated package. They know design. More important, they know the application of design to glass. And supplementing the Duraglass Center activities having to do with the physical aspect of the glass package, we have the market development work of consumer and marketing research. Publicity. Advertising. Merchandising. Display. And films to project ideas of interest to all industry groups. For example, these are scenes from film reports on the departmentalization of drugstores and improvement of prescription departments. All these market development activities are coordinated to help promote an ever greater demand for glass-packed products, to be our eyes and ears on retail and consumer attitudes. We most surely do not know all such answers, but we are better equipped to understand these phases of your problems. So you see, it's no one thing, but a combination of fine manufacturing facilities, fine people, never-ending interest in controlled, uniform quality, continuous search for improved methods of manufacture, and particular concern for the efficiency and economy of our containers in use. It's the combination of all these things that is represented by the names Owens-Illinois and Duraglass. Well, I'd like to say it's been good to have you as guests on this foot-saver tour of ours. Can't help but feel that getting better acquainted like this makes for a more pleasant and understanding association all around. And I'd like to extend an invitation for you to visit our Owens-Illinois facilities in person, because when you get right down to it, there's nothing like seeing the real thing. Just as in the market, there's nothing like seeing the real thing through glass. It's been nice talking to you. Goodbye.